The bomb that should have killed her landed 17 feet away, failed to explode, and sat there hissing like a venomous snake, while Eleanor Hartley stared at it through the shattered window of her laboratory. Time fractured into crystalline moments. The acrid smell of cordite mixed with brick dust. Broken glass scattered across her calculations like deadly confetti. The metal cylinder, painted dull gray with German markings still visible, had punched through the roof of the Imperial College building and embedded itself in the wooden floor at a 45-degree angle. Steam or smoke, she couldn't tell which, rose from its surface in lazy spirals. Her hands were shaking. Not from fear, though fear was certainly present, coiling in her stomach like barbed wire. No, her hands shook because she understood exactly what she was looking at. Eleanor had spent the last 8 months studying explosive mechanisms, detonation sequences, and the precise engineering that transformed inert metal and chemicals into instruments of death. She knew that inside that bomb, somewhere in its mechanical heart, a fuse was counting down or malfunctioning or doing something unpredictable. She should run. Every rational cell in her body screamed at her to run. Instead, Eleanor Hartley took 3 careful steps forward, her sensible Oxford shoes crunching on broken glass, and looked closer. London, September 1940. The Blitz had transformed one of the world's great cities into a nightly vision of hell. For 57 consecutive nights, German bombers would cross the channel, their Heinkel He 111s and Dornier Do 17s droning through the darkness like mechanical locusts, and rain destruction on military installations, dockyards, factories, and, inevitably, whether by design or miscalculation, on homes, hospitals, and schools. Eleanor had been working late, as she did every night. Sleep felt like a luxury Britain could no longer afford, and she was determined to carry her share of the burden. At 32 years old, Dr. Eleanor Hartley possessed one of the finest mathematical minds in the Commonwealth. She had studied at Cambridge when women were still denied degrees, despite completing the same rigorous coursework as men. She had fought for every equation, every formula, every shred of respect in a field that viewed her gender as a curiosity at best and an aberration at worst. Then the war came, and suddenly, her expertise in mechanical engineering and applied mathematics made her valuable, indispensable even. The War Office had recruited her quietly, without fanfare, and assigned her to a project so classified that even now, standing in a room with an unexploded German bomb, she couldn't fully articulate what she was working on to anyone without proper clearance. She was designing a fuse. Not just any fuse, but a proximity fuse, a device that could detect when an artillery shell or anti-aircraft round was near its target and detonate automatically without impact. The Americans were working on something similar, she'd heard through whispered conversations in secured rooms. But Britain needed its own solution, and they needed it months ago. The problem was devastatingly complex. How do you create a mechanism small enough to fit inside a shell, robust enough to survive being fired from a gun at forces that would crush a human body instantly, sensitive enough to detect an enemy aircraft at precisely the right distance, and reliable enough to work every single time? One failure rate of 10% meant 1 in 10 shells wasted. At 20%, you might as well be throwing stones at the Luftwaffe. Eleanor had covered her laboratory walls with calculations. Differential equations sprawled across blackboards in white chalk. Diagrams of radio circuits, vacuum tubes, and mechanical triggers covered every available surface. She dreamed in mathematics now, her subconscious working through problems while her conscious mind tried desperately to snatch a few hours of rest. And now, here was the enemy's solution to the same problem, delivered directly into her laboratory by the violent hand of war itself. The bomb continued its ominous hissing. Eleanor's mind raced through possibilities. The fuse mechanism had clearly failed, that much was obvious. But why? Mechanical failure? Electrical malfunction? Design flaw? Each possibility opened avenues of understanding that could prove invaluable to her own work. Outside, the air raid sirens continued their mournful wail. She could hear the distant crump of explosions, the staccato bark of anti-aircraft guns in Hyde Park, the drone of aircraft engines overhead. Somewhere, people were dying. Somewhere, families huddled in shelters were praying that the next bomb would fall on someone else's street, someone else's home. The mathematics of survival reduced to nothing more than random chance and the cruel calculus of statistics. Eleanor knew she should call the bomb disposal squad. There were men trained for this. Brave men who suited up in heavy padding that would do precisely nothing if the device actually detonated, and attempted to render these things safe. She'd met some of them, had taken tea with a young lieutenant named Cooper, who defused bombs with the same calm deliberation one might use to solve a crossword puzzle. He'd been killed 3 weeks ago in Stepney. The bomb he'd been working on had simply decided, for reasons known only to German engineering and cosmic chance, to explode. She thought about her sister Margaret in Southampton, who had evacuated her 2 children to the countryside and refused to leave herself, insisting someone had to keep the bookshop open because Hitler won't rob us of our stories. She thought about her father, a great war veteran who'd survived the Somme only to die of influenza in 1919, just months before coming home. She thought about all the brilliant work she hadn't yet completed, all the problems unsolved, all the potential locked inside her that would be erased in an instant if that bomb decided to fulfill its purpose. Then she thought about the 60 million people across the empire and the occupied nations, all fighting in their own ways, all making calculations about risk and necessity, all choosing between safety and duty 100 times each day. Eleanor pulled a notebook from her satchel and began to sketch. The bomb's casing showed impact damage near the nose cone. She documented the angle, estimated the velocity, noted the way the floor had splintered around the point of entry. Her hands had stopped shaking. Focus had that effect. It narrowed the universe down to the problem at hand, pushed fear to the periphery where it could only whisper instead of scream. She couldn't see the fuse mechanism without getting closer, perhaps even touching the device. That would be monumentally stupid. That would be the kind of decision that ended with newspaper obituaries using words like dedicated and brilliant and tragic. Eleanor set down her notebook and walked to the far end of the laboratory. In a metal cabinet, she found what she was looking for: a telescoping inspection mirror, the kind dentists used, and a powerful electric torch. She also grabbed a long wooden ruler and a magnifying glass. Back at the bomb, she knelt carefully, mindful of the broken glass, and extended the mirror on its handle, angling it to catch the light from her torch. The nose cone had cracked on impact, revealing a glimpse of the mechanism inside. She could see wiring, the edge of what might be a pressure plate or contact switch, and something that looked like a small electric motor. Her heart rate accelerated. This was different from the designs she'd studied in intelligence briefings. More sophisticated. The Germans were innovating, adapting, improving, which meant Britain had to do the same, only faster. She sketched frantically, capturing every detail she could see, making notes about materials and apparent construction methods. This was intelligence worth dying for, if she could get it to the right people. If she survived the next 5 minutes. The hissing sound changed pitch slightly. Eleanor froze, mirror still extended, barely breathing. Was the fuse mechanism cycling through some delayed sequence? Was it gathering energy for detonation? Or was it simply venting pressure, a dying machine's last gasp? In that moment, suspended between life and death, Eleanor understood something profound about the work she was doing. Every bomb, every shell, every bullet was a delivery system for mathematics. Humans had taken the pure language of the universe, numbers, ratios, geometric principles, and weaponized it. Her job was to make that mathematics more efficient, more deadly, more precise. She was helping to kill people more effectively. But those people were trying to kill her countrymen. They had killed Cooper, had killed thousands of civilians, had bombed hospitals and churches and homes. The mathematics didn't care about morality. The equations remained true, whether you were calculating the trajectory of a bomb or the orbit of a planet. She finished her sketch, added final measurements using the ruler to gauge scale, and slowly, carefully, began to back away from the device. That's when she heard footsteps thundering up the stairwell. "Get out! Unexploded bomb! Everyone out now!" The voice belonged to an air raid warden, probably doing his rounds, probably having spotted the hole in the roof from the street. In seconds, he would burst through the door and see her kneeling next to a German bomb with a notebook and a mirror like some kind of deranged academic on a field study. Eleanor grabbed her satchel, stuffed her notes inside, and moved toward the door just as it flew open. The warden was middle-aged, breathing hard, his face streaked with soot and sweat beneath his tin helmet. "Doctor?" "Hartley, thank God. We need to evacuate the entire block." "I know," she said calmly, pulling him back into the hallway. "But I need you to get me to a telephone immediately. There's intelligence here that the War Office needs to see within the hour." The warden stared at her as if she'd sprouted a second head. "Ma'am, with respect, we need to run." "We will. But first, the telephone." Something in her voice, the steel beneath the proper Cambridge accent perhaps, or the absolute certainty in her eyes, made him nod. They ran together through corridors lit by emergency lamps, down 4 flights of stairs, and burst out into a London street transformed into something from a nightmare. Buildings burned like enormous candles. The sky glowed orange and red, illuminated by fires that consumed whole city blocks. Smoke hung thick enough to taste, and the air vibrated with the constant percussion of explosives and anti-aircraft fire. The warden led her to a sandbagged post where a telephone line had been maintained for emergency services. Eleanor's hands shook again as she dialed the number she'd memorized on her first day at the War Office. It rang 4 times, each ring an eternity, while behind her, somewhere in that building, a German bomb continued its mysterious countdown. "Whitehall Extension 773. This is Dr. Eleanor Hartley. Authorization code Zebra 9 Queen. I need to speak with Colonel Harrison immediately. I have critical intelligence on enemy ordnance design." There was a pause, shuffling papers, then a different voice, cultured and precise. "Hartley, what have you found?" She described what she'd seen in 2 minutes of compressed technical language that would mean nothing to the warden standing guard beside her, and everything to the men who needed this information. She described the fuse mechanism, the unusual motor assembly, the advanced construction that suggested German engineering had made leaps forward in the weeks since their last intelligence update. "Can you retrieve the device?" Colonel Harrison asked. Eleanor looked back at the building. Smoke now poured from the hole in the roof. The bomb might detonate any second, or it might sit there inert for hours until the disposal squad arrived, or it might explode the moment someone tried to move it. "Negative," she said. "Too unstable. But I have detailed sketches. I can have working diagrams to you by morning." "Morning's too late, Hartley. We're briefing the cabinet tomorrow afternoon on anti-aircraft improvements. Your proximity fuse needs to be ready for testing by month's end, or the project gets reassigned to the Americans." The line went dead. Eleanor stood in the street, surrounded by war, and felt the weight of expectation settle on her shoulders like a physical thing. They weren't just asking her to be brilliant. They were asking her to be brilliant faster, under impossible conditions, while bombs fell around her and the fate of the air defense of Britain hung in the balance. The warden touched her elbow gently. "We need to move, ma'am. Further away from the building." Eleanor nodded and let him guide her toward a public shelter. Behind them, the Imperial College building stood defiant against the burning sky, holding within it a piece of German engineering that had tried to kill her and might yet succeed. But she had stolen its secrets first, had taken measurements and made calculations even as death hissed at her feet. As they descended into the shelter, joining the pressed mass of humanity seeking safety in the underground, Eleanor clutched her satchel and began working through equations in her mind. She had until morning to transform rough sketches into actionable intelligence. She had until month's end to solve a problem that had stymied some of the finest minds in the Commonwealth. And she had to do it while the Luftwaffe bombed London every night, while resources dwindled, while men died in fields and skies and streets for want of better weapons, better defenses, better mathematics. The bomb hadn't killed her. Now she had to make that survival mean something. Around her, people huddled in the dark, sharing cigarettes and quiet conversations, singing songs to keep spirits up. An old woman was teaching children a nursery rhyme. A young couple held hands so tightly their knuckles had gone white. Humanity, Eleanor thought, was remarkably resilient. It bent under pressure but refused to break. It found joy in darkness and hope in rubble. It kept going because the alternative was unthinkable. She would keep going too. She would solve this puzzle, perfect this fuse, and give her country a weapon that could pluck German bombers from the sky before they could rain death on cities. Not for glory or recognition or even gratitude. She would do it because she was one of the few people alive who possessed both the knowledge and the opportunity to make a difference. The mathematics didn't lie. The equations remained true. And somewhere in those pure, perfect numbers lay the key to survival. Not just hers, but perhaps for all the souls huddled in the darkness, waiting for dawn. Eleanor didn't sleep that night, though her body begged for it with every aching muscle and burning eye. The shelter had released its occupants at dawn when the all-clear sounded, and she had emerged into a London transformed. Where buildings had stood yesterday, mountains of rubble now dominated the skyline. Fire crews worked desperately to contain blazes that had burned all night. The Thames reflected a sky stained with smoke, turning the river into a ribbon of ash-gray silk threaded through the wounded city. She made her way through streets littered with glass and debris, past exhausted wardens and hollow-eyed families returning to homes that might or might not still exist. Her shoes crunched on broken brick. The air tasted of burned wood and something else, something chemical and bitter that coated her throat with each breath. The War Office occupied a nondescript building in Whitehall, its windows taped against blast damage, sandbags stacked 10 feet high around its entrances. Eleanor showed her credentials to 3 different checkpoints before being escorted to a basement room that smelled of cigarette smoke, strong tea, and desperation. Colonel Harrison was waiting, along with 2 other men she didn't recognize. One wore the uniform of the Royal Air Force, wings prominent on his chest, his face carved into harsh lines by too many missions and too little sleep. The other was civilian, older, with thick spectacles and ink stains on his fingers. Another scientist, she guessed, though from which institution she couldn't say. "Dr. Hartley," Harrison said without preamble, "show us what you found." She spread her sketches across the table, diagrams still smelling faintly of the graphite pencil she'd used to render them in the pre-dawn hours. Her hands had finally stopped shaking, steadied by purpose and the kind of exhausted clarity that comes after surviving something that should have killed you. "The German fuse mechanism is more sophisticated than our intelligence suggested," she began, pointing to the detailed drawing of the motor assembly. "They're using a clockwork delay combined with what appears to be a barometric trigger. The device measures altitude changes during descent and arms itself only after passing through a specific pressure threshold." The RAF officer leaned forward, his eyes sharp despite obvious fatigue. "Which explains why so many of their bombs fail to detonate on soft targets. The mechanism expects a certain rate of descent." "Precisely, Wing Commander. When a bomb strikes soft earth or penetrates through roofing before hitting solid structure, the pressure sequence gets disrupted. The clockwork continues, but the barometric component never receives its activation signal." Eleanor pulled out another sketch. "But here's what's interesting, and potentially exploitable." She traced the wiring diagram she'd glimpsed through the cracked nose cone. "They're using copper wire with a specific gauge, which means specific electrical resistance. If we can determine the exact specifications, we can predict failure modes. More importantly, we can understand their design philosophy and apply inverse principles to our own proximity fuse." The civilian scientist spoke for the first time, his voice carrying the soft burr of Scotland. "You're suggesting we learn from their mistakes." "I'm suggesting we learn from everything, Dr. Mackenzie. Robert Mackenzie. I've been consulting on the radar component of your proximity fuse." He studied her sketches with the intensity of a jeweler examining diamonds. "This is remarkable work, Dr. Hartley, particularly given the circumstances under which you obtained it." Harrison cleared his throat. "Which brings us to the unpleasant matter at hand. Dr. Hartley, what you did last night was extraordinarily reckless. You should have evacuated immediately and let the bomb disposal teams handle the device." Eleanor met his gaze without flinching. "With respect, Colonel, bomb disposal teams render devices safe. They don't conduct technical intelligence gathering. By the time they'd finished, the mechanism could have been damaged or destroyed. I saw an opportunity, and I took it. You could have been killed. People are being killed every night, sir. The question is whether my death would have served any purpose. Last night, I chose to make sure that if I died, it would at least contribute something to our understanding of enemy ordnance. She paused, then added more quietly, I'm not being cavalier about my life, but I am being realistic about the circumstances we face. The wing commander made a sound that might have been a laugh or a cough. I like her, Harrison. She's got spine. Harrison's expression remained stern, but something flickered in his eyes. Respect, perhaps, or recognition of a kindred spirit who understood that war demanded difficult calculations about acceptable risk. Nevertheless, Dr. Hartley, your value lies in your intellect, not your courage. We need you alive and working. Is that clear? Crystal clear, sir? Good. Now, walk us through your proximity fuse design. Mackenzie and the wing commander have concerns about the radar component's durability under firing stress. For the next 3 hours, Eleanor presented her work, defended her calculations, and engaged in the kind of intense technical debate that would have thrilled her in peacetime. The proximity fuse concept was elegant in theory, but diabolically complex in execution. A radio transmitter and receiver, miniaturized to fit inside an artillery shell, would emit signals and measure their reflection off nearby objects. When the reflected signal reached a certain strength, indicating proximity to a target, the fuse would trigger detonation. The problem was making the entire apparatus survive being fired from a gun. The acceleration forces inside a gun barrel could reach 20,000 times the force of gravity. Electronic components that worked perfectly on a laboratory bench would be crushed to powder or shaken into dysfunction by those forces. The vacuum tubes are the weak point, Mackenzie said, tapping one of Eleanor's circuit diagrams. We've tested 17 different configurations. All of them failed under firing stress. Eleanor studied the diagram, her mind racing through possibilities. The vacuum tubes were essential. They amplified the radio signals and controlled the triggering mechanism. But they were also fragile, with delicate glass envelopes and internal elements that could shatter or dislodge under extreme acceleration. What if we're approaching this wrong? She said slowly. We're trying to make existing vacuum tube technology survive forces it was never designed to handle. What if we design new tubes from the ground up, specifically engineered for these conditions? The wing commander frowned. That would take months. We don't have months. I've got squadrons fighting with equipment from the last war while German bombers come over with the latest technology every night. I know, Eleanor said, but the alternative is deploying a system that fails 70% of the time. That's not a weapon, wing commander. That's the expensive way to annoy the enemy. She's right, Mackenzie said. Better to take the time to do it properly than rush out something that doesn't work. Harrison had been silent during this exchange, but now he stood and walked to the window, looking out at the sandbagged street. You've got 6 weeks, he said without turning around. 6 weeks to design new vacuum tubes, test them, and deliver a working prototype. After that, the decision goes above my head. The Americans are offering to share their proximity fuse technology if we agree to certain terms. Terms that would essentially mean British anti-aircraft defenses become dependent on American manufacturing. Eleanor understood the implications immediately. It wasn't just about pride or nationalism. It was about strategic independence, about maintaining Britain's ability to defend itself without relying entirely on supplies that had to cross a submarine-infested Atlantic. Every shipment lost meant weapons that never arrived, technology that couldn't be deployed, soldiers left vulnerable. 6 weeks, she repeated. I'll need resources, access to the best vacuum tube manufacturers, unlimited testing time, and at least 3 skilled assistants who can work around the clock. You'll have 2 assistants, Harrison said. Resources are stretched across every front. Make do. Eleanor felt frustration rise in her chest but pushed it down. Arguing was pointless. Everyone was being asked to make do, to achieve miracles with inadequate resources and impossible timelines. That was the nature of total war. It demanded everything from everyone and never apologized for the asking. Then I'll need authorization to conscript specific individuals, she said. I know 2 engineers who have the skills I need. They're currently assigned to other projects, but give me their names. I'll see what I can do. Harrison finally turned from the window. Dr. Hartley, I want you to understand something. This proximity fuse could change the entire character of the air war. Right now, our anti-aircraft guns are firing shells that have to score direct hits to be effective. Direct hits on aircraft moving at 300 miles per hour, often at night, often through clouds. The hit rate is abysmal. But if your fuse works, if shells can detonate when they're merely close to an enemy aircraft, we could increase effectiveness by an order of magnitude. He walked back to the table, placing both hands on its surface, leaning forward with an intensity that made the room feel smaller. That means more German bombers shot down, fewer bombs falling on London, on Coventry, on Liverpool, fewer civilians killed, fewer homes destroyed. The mathematics are simple, Dr. Hartley. Your work could save thousands of lives. The weight of that responsibility settled over her like a physical thing. Thousands of lives, mothers and fathers and children. People like the families she'd sheltered with last night, huddled in the dark, singing songs to keep fear at bay. I understand, sir, she said quietly. I hope you do, because I'm going to be demanding the impossible from you over the next 6 weeks, and I need to know you won't break under the pressure. Eleanor thought about her father, coming home from the Somme changed, haunted, but unbroken. She thought about Margaret, refusing to evacuate, keeping the bookshop open because stories mattered. She thought about Lieutenant Cooper, who had defused bombs knowing any one of them might be his last, and who had done it anyway because someone had to. I won't break, she said. Harrison nodded. Then get to work. The meeting ended with handshakes and the exchange of classified documents that Eleanor would need for her research. Mackenzie offered to walk her out, and they climbed from the basement into daylight that seemed too bright, too normal for a world at war. You've taken on a hell of a task, Mackenzie said, as they emerged onto the street. 6 weeks isn't nearly enough time. I know, but it's the time we have, so it'll have to be enough. Eleanor looked up at the sky, clear blue now, innocent of aircraft. In a few hours, that would change. The bombers would come again, and people would die again, and the war would grind forward with its terrible, inexorable momentum. You're not alone in this, Mackenzie said. I'll provide whatever support I can with the radio components. And there are others. Good people, brilliant minds, all working toward the same goal. Don't let Harrison's gruffness fool you. He knows what you're capable of. That's why he's asking so much. Eleanor smiled, though it felt fragile. Thank you, Dr. Mackenzie. I should go. I have a great deal of work ahead of me. She walked back through London's wounded streets, her mind already racing ahead to the problems she needed to solve. Vacuum tubes that could survive 20,000 G-forces. Circuits that could operate reliably in the microseconds after firing. Radio transmitters small enough to fit inside a shell casing, but powerful enough to detect aircraft at useful ranges. Each problem was a mountain. Together, they formed a mountain range. And she had 6 weeks to climb them all. But as she walked, Eleanor felt something unexpected. Excitement. Not the grim determination of duty, but genuine scientific excitement. This was the kind of problem that made her become a physicist in the first place. It was complex, elegant, and world-changingly important. Success would require her to push the boundaries of what was possible, to innovate and improvise and think in ways that had never been attempted. The war had taken so much. Her peace, her security, her ability to conduct research without the shadow of death hanging over every equation. But it had also given her this, a purpose so clear and vital that every waking moment felt charged with meaning. She reached her temporary laboratory, a requisitioned space in a building that had survived last night's bombing through luck rather than planning, and found a note pinned to the door. 2 names, hastily scrawled, Thomas Whitmore and Alice Chen, her assistants. Harrison had moved fast. Eleanor unlocked the door and stepped into a space that smelled of solder and machine oil. Blackboards covered every wall, filled with equations from her previous work. Workbenches held oscilloscopes, testing equipment, and prototypes in various stages of completion. This was her domain, her fortress against chaos. Here, the rules were mathematical and absolute. Here, she could find answers. She rolled up her sleeves, cleared a fresh section of blackboard, and began to write. The vacuum tube problem had to be solved first. It was the foundation upon which everything else rested. She started with first principles, calculating the forces involved, the material stresses, the potential failure modes. Hours passed. Tea grew cold in a forgotten cup. Outside, the city lived and breathed and prepared for another night of fire. But in this room, time contracted to the space between chalk strokes, to the elegant unfurling of mathematical truth. Eleanor was still working when the door opened, and two people entered. A tall young man with wire-rimmed glasses and a Chinese woman about Eleanor's age, both carrying cases of tools and documents. "Dr. Hartley, I'm Whitmore. This is Dr. Chen. Colonel Harrison sent us." Eleanor turned from the blackboard, blinking as if waking from a dream. "Yes, good. I need you to understand something before we begin. We have 6 weeks to accomplish what should take 6 months. That means we work every day, long hours, under conditions that will test every limit you have. If you're not prepared for that, leave now." Whitmore and Chen exchanged glances. Then Chen spoke, her accent carrying traces of Cambridge education, layered over Beijing roots. "Dr. Hartley, my family is in Shanghai. The Japanese are doing terrible things there. If I can contribute something here, anything that helps end this war faster, then I'm prepared to work every hour God sends. Sleep is a luxury none of us can afford." "I'm in," Whitmore said simply. "What do you need?" Eleanor felt something loosen in her chest. Not quite hope, but perhaps its cousin. "I need you to help me build the impossible." She explained the proximity fuse concept, the vacuum tube problem, and the crushing deadline they faced. She showed them her calculations, her designs, and the intelligence she'd gathered from the German bomb. And as they listened, she saw in their eyes the same fire that burned in her own, the determination to solve this puzzle, to beat the deadline, to give Britain a weapon that could turn the tide. "Where do we start?" Chen asked. Eleanor smiled. "With mathematics, always with mathematics." 3 weeks into the project, Eleanor stood in a testing bunker 30 miles outside London and watched her 9th prototype explode into fragments. The test gun, a modified anti-aircraft cannon bolted to a concrete platform, had fired the shell containing her latest vacuum tube design at a target drone flying at 2,000 feet. The shell should have detonated when it passed within 50 feet of the drone, demonstrating the proximity fuse's effectiveness. Instead, the electronics had failed catastrophically during firing, and the shell had tumbled harmlessly into the countryside beyond. "That's 9 failures," Whitmore said quietly, marking another entry in his test log. His optimism from 3 weeks ago had worn thin, replaced by a weary determination that Eleanor recognized in her own mirror each morning. Chen was already retrieving fragments from the impact crater, her practiced hands sifting through twisted metal and scorched components. "Same failure mode," she called back. "The vacuum tube's internal elements have sheared away from their mounting points. The acceleration forces are just too extreme." Eleanor felt exhaustion pressing down on her like a physical weight. They had been working 18-hour days, 7 days a week. The laboratory had become their world, a universe bounded by blackboards and testing benches, lit by the harsh glow of electric lamps and punctuated by the nightly wail of air raid sirens. She couldn't remember the last time she'd slept more than 4 hours consecutively. The German bombing campaign continued relentlessly. Every night, the Luftwaffe came. Every night, British anti-aircraft guns fired thousands of shells with conventional fuses, scoring occasional hits through sheer volume of fire and luck. Every night, bombs fell on cities and people died, and the pressure to succeed mounted higher. "We need to completely redesign the tube structure," Eleanor said, forcing her mind to focus despite the fog of exhaustion. "The problem isn't the materials, it's the fundamental architecture. We're trying to protect delicate elements through reinforcement. But what we need is a design where the elements themselves are robust enough not to require protection. That's theoretically impossible, Whitmore said, not argumentatively, but as a simple statement of fact. Vacuum tubes require precise spacing between elements. Any deformation destroys functionality. Then we change what's possible. Eleanor walked to where Chen was examining fragments, kneeling beside her in the dirt. A piece of the vacuum tube's glass envelope caught the afternoon light, its inner surface showing a delicate pattern of metal deposits, the cathode coating that had torn away during firing. She held the fragment up, turning it slowly, and something clicked in her mind. A connection between separate problems, a bridge between impossible requirements. What if we eliminate the glass entirely? Chen looked up sharply. Metal envelope tubes? That's been tried. The sealing is too difficult and… Not metal envelope. Ceramic. Eleanor stood abruptly, her exhaustion forgotten in the sudden rush of insight. Ceramic bodies with metal end caps. Ceramic can withstand enormous compression forces, and we can design the internal elements to be self-supporting through the ceramic structure, rather than suspended in vacuum. Whitmore was already flipping through his reference materials. The Germans have experimented with ceramic tubes for radio applications, but nothing that would survive gun firing. The thermal expansion coefficients can be managed with proper material selection and manufacturing tolerances, Eleanor finished. Yes, it's difficult. Yes, it's never been done at this scale. But it's possible, and that's all that matters. They drove back to London in gathering dusk, Eleanor's mind racing through calculations while Whitmore drove and Chen sketched preliminary designs in a notebook balanced on her knee. The city appeared on the horizon like a living thing, its lights carefully darkened against air raids, its skyline punctuated by gaps where buildings had stood before the bombing. At the laboratory, they worked through the night. Eleanor filled blackboards with thermal expansion calculations, while Chen drafted detailed cross-sections of the proposed ceramic tube design, and Whitmore contacted manufacturers to determine if anyone could produce ceramics with the required specifications. There's a pottery works in Stoke-on-Trent, Whitmore reported around 3 in the morning, his voice hoarse from telephone conversations. They've been producing ceramic insulators for high-voltage applications. The owner thinks they can achieve the tolerances we need, but it'll require custom tooling and at least 2 weeks of testing. We don't have 2 weeks, Eleanor said. We have 12 days until Colonel Harrison expects a working prototype. She stared at the blackboard, at the elegant equations that described what should be possible. Tell them we'll pay double for priority work, triple if they can deliver in 10 days. The budget? Damn the budget. If this doesn't work, the budget is irrelevant. If it does work, saving even one ship or one squadron makes the cost meaningless. Whitmore nodded and returned to the telephone. Chen brought Eleanor a cup of tea that had long since gone cold, pressing it into her hands anyway. You need to rest, she said quietly. Even for an hour. You're no good to anyone if you collapse. I'll rest when we have a working prototype. Eleanor. Chen's use of her first name cut through the professional distance they'd maintained. I've watched my family's letters become fewer and more desperate as the war in China drags on. I know what it's like to feel that every moment not working is a moment wasted, but you're the only one who can see the complete picture of this project. If you burn out, we all fail. Eleanor wanted to argue, but the truth of Chen's words was undeniable. She was running on fumes and mathematical obsession, and neither was sustainable. 2 hours, she conceded. Set an alarm. She collapsed onto a cot they'd set up in the corner of the laboratory, and sleep claimed her instantly, pulling her down into dreams filled with fragmenting shells and equations that dissolved before she could solve them. The alarm woke her exactly 2 hours later. She rose feeling marginally more human, splashed cold water on her face from a basin, and returned to work. The ceramic tube design had crystallized in her subconscious during those brief hours of sleep, and she attacked the blackboard with renewed energy, refining calculations and adding details. By dawn, they had a complete design package ready to send to Stoke-on-Trent. By noon, They received confirmation that the Pottery Works would begin manufacturing test samples immediately. By evening, Eleanor was back in Whitehall, presenting their progress to Colonel Harrison and a room full of skeptical military officers. "Ceramic vacuum tubes," one RAF group captain said flatly. "You're betting Britain's air defense on pottery." "I'm betting on materials science and engineering principles that have been validated through rigorous testing," Eleanor replied, keeping her voice level despite her irritation. "Ceramic has a compressive strength far exceeding glass and thermal properties that make it ideal for the extreme conditions inside a gun barrel. And if you're wrong, then we'll have spent 3 weeks pursuing a solution that didn't work, which is exactly what would have happened if we'd pursued any other approach. At least this way, we're pushing the boundaries of what's possible, rather than accepting what's merely conventional." Harrison cut off further debate with a raised hand. "Doctor, Hartley has my full confidence. The question isn't whether to pursue this approach, it's whether it can be delivered on time." He fixed Eleanor with a hard stare. "Can it?" She thought about the Pottery Works in Stoke-on-Trent, racing against the clock. She thought about Whitmore's calculations on circuit stability and Chen's refinements to the radio transmission system. She thought about all the variables, all the things that could go wrong, all the impossible precision required. "Yes," she said. 7 days later, a delivery truck arrived at the laboratory carrying a wooden crate packed with ceramic tube samples. Eleanor opened it with hands that trembled, not from fear this time, but from anticipation. The tubes were beautiful in their way, precisely manufactured pieces of ceramic that represented the culmination of everything they'd learned. "Testing begins immediately," she announced. They spent 48 hours subjecting the tubes to every stress test they could devise. Temperature cycling from -40 degrees Celsius to +80, vibration testing that rattled the laboratory's windows, and finally, acceleration testing, using a specially modified centrifuge that could simulate the forces of gunfiring. The first tube cracked under stress. The second survived, but showed electrical anomalies. The third performed flawlessly. "It works," Chen whispered, staring at the oscilloscope readings as if they might disappear. "Eleanor, it actually works." Whitmore was laughing, a sound of pure relief and triumph. "We need to test a complete fuse assembly. If the tube survives integrated testing." "We test it tomorrow," Eleanor said. "Tonight we sleep. Actual sleep, in actual beds. Tomorrow, we find out if we've succeeded or just gotten lucky with a single component." She sent them home, then sat alone in the laboratory for a long time, looking at the ceramic tube that represented so much work, so many sleepless nights, so much hope. Outside, London prepared for another night of bombing. Air raid sirens would sound. People would crowd into shelters. German bombers would come, and British gunners would fire thousands of shells, and mostly those shells would miss because hitting a moving aircraft at night with conventional fuses required either extraordinary skill or extraordinary luck. But soon, perhaps very soon, those gunners would have proximity fuses, shells that didn't need direct hits, a weapon that could change the character of the air war. If this tube worked, if the integrated assembly worked, if. Eleanor finally went home to the small flat she'd barely seen in weeks, collapsed into bed still wearing her clothes, and slept for 10 hours straight. The final test took place on a cold morning with low clouds threatening rain. Eleanor, Chen, and Whitmore stood in the testing bunker with Colonel Harrison, Dr. Mackenzie, and a delegation of military observers who had come to witness either a triumph or an expensive failure. The shell, containing Eleanor's proximity fuse with its ceramic vacuum tubes, radio transmitter, and carefully calibrated triggering mechanism, sat loaded in the test gun. A drone aircraft flew a programmed pattern at 2,000 feet, representing an enemy bomber. Everything came down to the next 30 seconds. "Fire when ready," Harrison said quietly. The gun crew acknowledged. Eleanor held her breath. The gun fired with a concussive blast that shook the bunker's concrete walls. For 2 heartbeats, nothing happened. Then, At precisely the moment Eleanor's calculations predicted, a flower of fire bloomed in the sky near the drone. The proximity fuse had detected the aircraft, measured the range, and detonated at optimal distance. The drone itself, built to survive near misses for testing purposes, flew on. But fragments from the shell had peppered its surface. In actual combat, those fragments would have shredded a bomber's control surfaces, punctured fuel tanks, killed crew members. The drone might continue flying, but it would be crippled, forced to abort its mission, or crash before reaching home. The bunker erupted in cheers. Whitmore was shaking her hand. Chen was crying openly. Harrison was smiling, actually smiling, for the first time Eleanor had ever witnessed. "Dr. Hartley," Harrison said, his voice carrying over the celebration. "You've done it. You've actually done it." Eleanor watched the drone disappearing into the clouds, its mission interrupted by mathematics made manifest, by ceramic and copper, and the precise application of physical principles. She thought about all the nights of work, all the failures that had led to this success, all the people who had contributed their expertise and effort. "We've done it," she corrected. "All of us. And now we need to get it into production immediately. Every day we delay means more aircraft get through, more bombs fall on cities." "Production is already being arranged," Harrison said. "We'll have the first combat-ready shells within 6 weeks. By autumn, proximity fuses will be standard issue for anti-aircraft batteries across Britain." Eleanor nodded, feeling suddenly exhausted despite her 10 hours of sleep. They had solved one problem, but the war continued. There would be new problems, new impossibilities to make possible. The work never ended. It simply evolved into new forms. But for today, for this moment, she allowed herself to feel what she'd been too busy to acknowledge: pride. Not in herself alone, but in the collaboration that had made this possible. In Chen's tireless work on circuit design, in Whitmore's manufacturing expertise, in Mackenzie's radio components, in all the pottery workers in Stoke-on-Trent who had produced ceramic tubes to tolerances they'd never attempted before. And yes, in her own refusal to accept that something was impossible simply because it had never been done. That night, as Eleanor finally returned to London and heard the air raid sirens begin their familiar wail, she didn't head for the shelters immediately. Instead, she stood on a rooftop and watched searchlights sweep the sky, listened to anti-aircraft guns bark their defiance at the incoming raiders. Soon, very soon, those guns would have her fuses. Soon, more bombers would fall from the sky. Soon, fewer bombs would reach their targets. It wouldn't end the war. No single weapon could do that. But it would save lives. Thousands of lives, if Harrison's estimates were correct. People who would live because she had refused to give up, had pushed through exhaustion and failure to find a solution. The mathematics had been true. The equations had held. And somewhere in those pure, perfect numbers, she had found not just a weapon, but a kind of salvation, for herself and for all the souls still fighting in the darkness. As the first bombs began to fall on distant neighborhoods, and the guns opened fire in response, Eleanor descended to the shelter, carrying with her the knowledge that she had made a difference. Not through grand gestures or heroic sacrifice, but through patient work, careful thought, and the stubborn insistence that the impossible was simply the possible that hadn't been achieved yet. The war would continue. She would continue with it, finding new problems to solve, new impossibilities to conquer. But tonight, finally, she could rest knowing that the mathematics of survival had shifted, however slightly, in Britain's favor. And sometimes, that shift was all that stood between darkness and dawn.